Hello everyone, welcome to my YouTube channel. Myself Kailash Kumar 1VE21CS074. Today we are learning a new topic, Boyce-Codd normal form, multiple value dependence and the fourth normal form. Let's start from the introduction. What do you mean by Boyce-Codd normal form? Boyce-Codd normal form BCNF is based as a functional dependency that takes into account all candidate keys in a relation. However, BCNF also has additional constraints compared with the general definition of 3NF. There are rules for BCNF. The first rule for BCNF is the table should be in the normal form. The second rule is X should be a super key for every function dependency FD X to Y in a given relation. Let's move to the next slide. Note: to test whether a relation is in BCNF, we identify all the determinants and make sure that they are in a candidate key. Let's see that 1NF, 2NF, and 3NF are in the determined manner in a candidate key. Let's move to the next slide. You come across a similar hierarchy known as the Comiskey normal form in the theory of the commutations. Now carefully study the hierarchy above. It can be inferred that every relation in the BCNF is also in 3NF. To put it another way, a relation in 3NF needed not be in a BCNF. Ponder over this statement for a while. Let's move to the next slide. There are some examples for Boyce-Codd normal method. Now, for example, we having a table. In table, we having a study ID, student branch, student ID, student branch, student code, branch number, and student course number. Now, in this, we are seeing a 101, 101, 102, 103. These are the student ID, and now the student branch is computer science and engineering, computer science and engineering. And there are two students of the same computer science and engineering, and the another two are electronic communications and engineering. This is an example for an Boyce-Codd normal method. Let's move to the next slide. Now the functional dependency of a above is as mentioned. Student ID is greater than student branch. Student course is greater than branch number. Student course number. Candidate key of an above are the student ID, student course. Why this table is not in a BCNF? The table present above is not in BCNF because as we can see there is neither student ID nor student course in a super key. As the rule mentioned above clear that the table for this is to be in BCNF, it must follow the property that for functional dependency x to the y, x must be in super key, and here the property fails. Just this is not an BCNF. Let's move to the next slide. This is example 2. For example, consider relation R of A, B, C, where A is greater than B, C and B is greater than A and B are both super key as the following relation is in the BCNF. Note BCNF decompose may always not be possible with dependency prevention, however. It always satisfies the lossless join conditional. For example, relation R, B, W, X, Y, Z is functional dependency. Let's move next slide. Multivalued dependency. Multivalued dependency would occur whenever two separate attributes in a given table happens to be independent of each other, and yet both of these depends on the third attribute. The multivalued dependency contains at least two of the attribute dependents on the third attribute. This is the reason why it's always constraint of at least three of the attribute. Example: suppose that there is a car manufacturing company that produce two of the colors in the market, red and the yellow of the each other model every year. There are some car models and the manual month and the color. The car models is S201, 211, 2001, S3001, S301, S406. January, February, March, April, May, June. There are some colors of these car models: yellow, red, yellow, red, yellow, red. Let's move to the next slide. In this case, the column colors and the manual month are depends on the car models, and they are independent of each other. Thus, we can call both of these column multi-value. These are as a result dependence on the car models. Here is a representation of a dependency we discussed above. Why do we use multi-value dependency in DBMS? We always use multi-value condition whenever we encounter these two different ways. when we want to test the relations are decided if this happens to be lawful under some arrangement of particles as well as multivalue dependency. When we want to determine what limitations are there on the arrangement of them lawful relations. Thus, we can be concurrent over self with just the relation that fulfill a due arrangement of particle as well as multivalue dependency. Representations of multivalue dependency in DBMS. Multivalue dependency in DBMS can represent using a notation similar to that used for a functional dependency. And MVD is represented by a double-headed arrow between two sets of attributes whenever the left-handed side is the substance of an attribute of relations and the right-handed side is a substance of attributes that are not functionally dependent on the LHS. For example, consider a relations of R of A, B, C, D, and where A is B and the B is C, and MBT exists between A and C if A tends to C. Conditionaling for multivalue dependency in DBMS exists. A multivalue dependency in DBMS exists between two sets of an attribute X and Y in the relations R if and only if there are two other set of attribute A and B, where X of A to R and the Y to B to R and the A and B are not functionally depends on each other, but they are functionally depends on X. In other words, there must be two subsets of R that are functionally depends on X but are not functionally depends on each other. Fourth normal form 4NF. Fourth normal form of 4NF is level of database normalizing that requires relation to be in BCNF and have no traveler multi-value dependence others that can be candidate key to be eliminated deleted data and the maintained data constantly if a table validate that this extends is needed to be split into two tables of achieving 4:7. To remove the multi-value dependency MVD in the student table example, we can create two new tables, one of the course and the other of the textbook, and establish a relation between these using the foreign key. This is a table, course ID and the course name. Just there are the subjects. Now this is a textbook. Now this is textbook name ID and the course one. Now we remove the multi-value dependence by splitting the course and textbook often into a separate table. We haven't added a new course ID column to the student table. It has to be foreign key that refers to the course ID column and the course table. Now hence we have achieved the fourth normal form for NF for the student table. It has been done after by removing the multi-value dependency, creating a separate table. The resultant scheme eliminates data redundancy and improve data integrating makes it easier to manage a query and the database. Challenging of a fourth normal form. Now, achieving the fourth NF can be challenged as it required carefully analyze all the function dependencies, selecting the appropriate key and balancing between the normalizing and the performance. Achieving 4NF can be time consuming. Now, the technique used for achieving fourth normal form is there are the several techniques for achieving 4NF, including using a joint dependence, splitting tables, and using an intersection tables. Example for achieving fourth normal form. An example for achieving fourth normal form is splitting a table with a EMVD into a two or more table with each other. Table containing attributes that are functionally depends on the primary key. In another example, estimating an MVD by creating a separate table that has to be linked to two tables of MVD. This is a conclusion. Multi-value difference is a concept which can be removed by 4NF. 4NF helps to implement data redundancy, improve data integrity, and improve database performance. Achieving 4NF can be challenges both, but it improves data quality, better database performance, and less anomalous accelerated that has redundancy. By analyzing functional dependency and using approximate techniques, 4NFs can be achieved. Thank you for watching my video. Kailash Kumar signing off. Have a nice day.